Thanks, everybody. So this is generating new async. My Twitter handle's up there. Feel free to heckle me during the talk because I'm not watching Twitter. So of course, first I want to talk a little bit about what generators are. And unfortunately, this will not work because this is a reveal presentation and it's bidirectional. So instead, I'm going to have to do that. So generators are a way for pausing and resuming function execution. And it sounds very simple when I say it like that, but it's a very confusing topic to a lot of people. The general idea is to have a function, be able to do some things in the function, pause that function, do some other things outside of the function, and come back and continue where you left off. That's the entire idea. It's really a very simple concept. This is new in ECMAScript 6, so I'll talk about where you can use it coming up toward the end of the presentation. First of all, generators are not asynchronous, and this is something that you might look at and say, well, then why the heck is this talk called Generating New Async? And we'll get to that. But let's back up a minute. I want to talk a little bit about asynchronous code. So you've got some asynchronous code up here on the screen. Obviously, this is a really simple set timeout. It logs a message after 1 millisecond. Very easy. And now I've got this long-running loop that does 50 million new objects, and that's going to take a little while. So even though your timeout here is going to execute after 1 millisecond, it doesn't really, right? What really happens is after 1 millisecond, that function gets added to the event loop's queue, and it's going to say, okay, the next tick of the event loop, I'm going to execute that thing. But it's not really because JavaScript is single-threaded. And so instead, this loop is going to keep going and going and going. So you get the long-running completion before you get the 1 millisecond timeout. And this is because JavaScript follows a run-to-completion paradigm, which is very simple. It just means that this code is going to run all the way to completion, from top to bottom, all the way through until it finishes. And nothing is going to disrupt that. Nothing can interrupt that unless, of course, the thread dies. So even though we're setting an asynchronous timeout here to execute after 1 millisecond, this for loop is going to block that execution, prevent the event loop from ever reaching the next tick, and so that 1 millisecond timeout won't happen. Generators don't solve this. And they're never going to solve it. They weren't intended to solve that. And we'll get to that in a little bit. But first, I want to talk about a solvable problem. Because we do have a solvable problem here that generators can help us with. So here we have a very simple file read. So I'm going to do the file system object in Node, and I'm going to access the read file method, and that read file method is going to read a file, and then it's going to check some errors and do whatever it needs to do. And that's all fine and dandy. You can think of this with any asynchronous activity. So it could be an AJAX call, it could be a set timeout, it can be anything that you want that is asynchronous. But we're going to use read files. And now I'm going to do another read file because I wanted to get some file based on the data from the first file. It's a fairly common action, and then maybe I need to do another one of those. And of course, at each level of this, I'm nesting these things in, and I've got callbacks, and I'm doing error checking, and all that other good stuff. And I've got functions inside functions, and that's really terrible. You get into callback hell. It's just really nasty. It's not that you can't do it, it's just that it's really nasty, and it can make testing very difficult. We could just make these things synchronous, right? So I could actually use in Node the read file sync method, or if you're just doing AJAX, you can set the asynchronous flag in the XML HTTP request object to false. And you could just do synchronous code, and oh, isn't that pretty? Except that that's kind of like making a realistic jumping height for the overweight plumber in Mario Brothers, right? It's like, it doesn't really do what you want. It's just like, yeah, okay, he can jump around and stuff, but that's not helpful. So instead, what we want to do is we want a methodology for writing code in an synchronous fashion, in a way that looks synchronous, but with all of those benefits, all those runtime benefits of asynchronicity. And so that's our goal. That's what we're going to try to achieve here. And that's where generators come into play. Again, remember, they're pausing and resuming execution. And you might imagine where we want them to pause is on an asynchronous activity. So that's what we're going to get to. But first, I want to talk a little bit more about this synchronous code, and I want to show you where we're headed. So we've got this synchronous example, and that's all pretty and stuff, but it's not helpful to us because there's no asynchronicity going on, and that's what we really want. This is where we're going to get to. Now, before you get to that code, we have to take a step back, and we need to talk about generators, right? Because it's a very different paradigm than you're probably used to. So let's look at just a simple generator. This one has 2 yield statements. I'm going to yield A, and I'm going to yield this object B, and I've got a couple of console log statements in there. 2 things to note, of course, the new keyword yield, but also look at that function definition. There's an asterisk there, right? Just a quick note, that asterisk can actually appear before the space or after the space between the keyword function and the name. But that indicates to the JavaScript interpreter that this is, in fact, a generator. The yield statement does not indicate it's a generator. This is how we're going to execute that generator. And there's a couple of weird things that you might notice about this. First of all, we execute the function, but that doesn't actually begin function execution. More properly, what it does is it gives you back an object, and that thing is a generator. So you have a generator function, it's going to return to you a generator object. That generator object you need to hold on to, so that's our first variable there. And then what we do is we call next on that generator object. So again, when we call the function the first time, we have not entered the function. We have not begun execution of the code inside that function. When we call next that first time, we begin execution at the top of the function, and it's going to go all the way through in a run to completion style until it hits a yield statement. And as soon as it hits a yield statement, the function pauses. And whatever value is after that yield gets put back in our object, and I'll get to that in a second. And then it comes out of the function. You can see we have a console log statement, and then we call next again, and it resumes execution from the first yield and goes up to the second yield. And then it pauses again. So this is the output we get. You can see that we get the console message inside the function, and then outside the function, and then back inside the function. Again, this is not breaking the run to completion paradigm. We are still executing that code from top to bottom. The only difference is we're allowed to meander about. So we're still single-threaded. There's still a single execution path. It's just that that path is a little more wibbly-wobbly, but not timey-wimey yet. The other thing that I want to point out here is that, of course, generators are yielding values. So I mentioned this a little bit earlier, but we're yielding values. In this case, we're yielding two values, the string A and the object with B in it. When we execute this function, you can see that I call next, and there's a returned value from next. And I'm storing that in the variables 1 and 2, and then I'm logging those out. And you can see that those variables have two things in them. They've got the value that was yielded, in this case a string A and the object with B in it, and they also have a done switch. And you can see that it's false. And in fact, it's false on both of those. Because remember, when I called next the first time, I began execution at the top and I went to the first yield. And I called next the second time and it resumed from the first yield and went to the second yield. But there could be more code after that second yield, right? You could have other stuff under there. So I need to actually call this generator method next again. And you can see that the return value now is undefined for the value, but done is true. So now we know the generator has finished execution, but you can see that we get an undefined value. We can actually get a defined value in there by adding a return statement. So in the last call to next on the generator object, it'll give us back whatever that returned value is. So in the third time, you can see we get value C. And the done switch is true. Good? Good. You notice that I kept calling next and next and next and next, and that's because generators are iterators. They implement the iterable interface. And this can be very helpful for doing certain things like, calculating the digits of pi, where you might want to pause that and let some other stuff go while you keep executing the digits of pi. But we're not really concern ourselves too much for that. I just want to show one quick example. Because they're iterators, we can actually loop over a generator function. So we're going to loop over a function. And that basically looks kind of like this in the most simplistic case. You can see we've got those two yield statements still. And we have another construct in ES6, which is the for of loop. So notice that the keyword there in the for loop arguments is actually of, not in or semicolons or what have you. The execution of foo in the for loop returns a generator object, right? And a generator object is an iterable object. And so the for of loop knows I'm going to call next on that thing until it returns a done of true. And whatever the value that's returned from that object, remember that comes back from the next call, I'm going to put that into, in this case, the variable called value, and then we can look at that inside. So that's a simple looping nature. Now, that's all great, but we're not really going to deal with them as iterables. We don't really care about that too much. In addition to being able to yield values to you, yields can also accept input. Basically, when we resume execution of the function, we can give that generator function input. So we can give it arguments at the start, but we can also give it input on each iteration of that pausing and resuming cycle. So here's a very simple fortune teller, and you can see it's got a yield statement at the top, and it says, tell me your fortune. When we execute this code, we create the generator object first, and we call next the first time. And remember, that begins execution, and it pauses at the first yield. Now, when I call next the second time on the second to bottom line there, I pass in Leo as my sign, which it is, into the next function, and that gets stored in the sign variable. So the yield expression becomes whatever value you pass into next on the second time or third time or whatever time you're on. And now I can evaluate that variable, do whatever I need to, yield again, and get that fortune out. So again, we can pass things into the generator function via the next call and the yield expression. Error handling in generators is actually really, really easy. I am not trolling you. It's actually really easy. It might look like it's difficult, but all we're going to do is throw and catch errors. That's it. It's really very, very simple. So here's a really simple function where we generate my lucky number 13, and you can see I've put a try-catch block around it. If an error occurs outside this generator, then I need to call the generator's throw method. But it's really very simple, so I get back the number 13 from the first call to next, and then I inspect that, I say 13, that's not a lucky number, it is. And then I call generator.throw with whatever error I need to do. The yield expression in the generator function becomes a throw new error, essentially. It becomes a throw new error, and so I actually catch that error in the generator function up above, and I can handle that error however I want to, do whatever I need to do, and then move on. If the error occurs inside the generator, however, it's actually even easier. All you do is throw an error. So if you allow the function execution to continue in my lucky number generator, we'll get to that last line and it'll throw an error, and all you do is in the surrounding code, the code where you're calling the generator, you just do a try-catch. That's it. It's very, very simple, so you can just throw and catch errors all day long. And this is going to be great for us as we're handling async code. So finally, we're going to get to some async programming, and we're going to start by the tools. And the first tool, of course, is generators, and you know that, and that's fine. But we need one other tool, and that's promises. And you might be saying, promises? And I'm saying, yes, promises. So the problem is, again, remember, generators are not asynchronous. But we need some way of indicating when a generator when an async action has completed. We need to know that, and we don't want to use callbacks because we don't want to get into callback hell. So we need some method for saying, hey, this asynchronous thing is done. And we're going to use promises for that. Now, you've seen promises in some of the other presentations here, so I'm not going to really go over them. But what if you have node-style callbacks and you're doing this in Node, or you're just doing something in JavaScript and you have a weird callback structure? Well, you can use one of these handy-dandy functions like denotify, which will actually convert that function into something that implements the promise interface. So we can do something like with our file system in Node, pass in the read file method on the file system object, get back a new function that will actually return to us a promise, and then when we call our new function called read file, we pass in the file we want to read, and then we call then, just like you would with any other promise, and the first argument would be the function for resolution, the second would be for rejection. And that's great. So that's one solution for node-style callbacks. You might say, but generators are cumbersome. You've got to do all these things. You've got to generate the actual object, and then you've got to call next the first time. You've got to check the value property. You've got to call next again, and you have to keep doing this over and over again. You've got to remember to use generator.throw. It's a lot of stuff. So instead, we're going to want something to abstract that interface away a little bit, because we don't care necessarily that they're iterable. That's helpful to us, but we don't really care about it. So what we're going to do is we're going to get a generator runner. And if you know that game, you're older than me. So the first thing that our runner needs to do is it needs to create a generator object. The second thing it needs to do is it needs to call next, right? So accept a generator function, create the generator object, call next that first time. When we get a promise yielded inside the generator, right? So something like our read file method, when it yields a promise object, it's going to wait for that promise object to resolve or reject. When it does, if it rejects, we'll throw an error. If it resolves, then we'll just keep going and go on to the next yielded promise. And this is what that might look like. Now, don't use this code, it's really bad. But it's a very good, simple implementation. You can see we accept the generator as our first argument, and we create the generator object right off the bat. And then we're going to implement this internal function called runGen, which is our recursively called generator runner. And the first thing it does, of course, is call next. And don't worry about the fact that it passes in a result. We'll get there, but that result basically is going to be your promise. So it's going to call generatorObject.next, and then it's going to check the returned value. Remember, that returned value is going to be whatever was yielded from the generator, and that's going to be a promise. So a promise is going to be the item, and we're going to check it's going to be in the value of the item, right? The item has a value and a done. It's going to check to see if that item is done, and if it's not, it's going to go to the value, which is our promise, and call then. So again, it's going to wait for that promise to resolve or reject. When that promise resolves or rejects, it just calls runGen again. And maybe it needs to call the generator object's throw method if there was a rejection. That's basically it. And then we just recursively call this thing over and over again. So now we have everything in place. This is what it looks like. So we've got our run method, and we're passing into the run method an anonymous generator function. In this function, we have 3 file reads. Remember, this is our denotified read file, yeah? So we call read file, we pass in the file name, and it returns a promise. And we yield that promise to our runner. And then our runner calls then on that promise object and waits for it to resolve or reject. So even though this looks very synchronous, each one of these things is happening in a synchronous fashion in the sense that we're doing one and waiting and then doing the next one and waiting. But the actual call to read file is asynchronous and the generator pauses while that happens. So this is completely asynchronous. When this finishes, we'll log out all three of those file contents and that's all great and dandy. But what if I did something like this? What if I added a set timeout up at the top before I executed this code and then I did my generator? What would happen? Well, again, because read file is asynchronous, even though the generator function has paused, the asynchronous action is still going on in the background, and so we're able to actually get our timeout and then our file reads. So we've turned that synchronous flow into an asynchronous flow by using generators with yielded promises. This was the example that I showed you before, the popcorn GIF, and you can see it's very simple. We do a yield to read the first file. We might do some parsing of that return data, and then we would read the next file based on that return data. So you can see that we can look at this and say, oh, well, that was a synchronous file read, but it's not. It's an asynchronous file read that yielded a promise for us that we then handled on the back end. So you might be saying, well, what about errors in all this process? How do I handle errors? Again, we're just throwing and catching errors. So if we're doing those 3 file reads in a row like that, we can just wrap that in a try-catch block. You can see that in this case, I'm actually pushing that returned file data onto an array. And that's all great and dandy, but you can see that third file has data infinity in it, and so obviously that file is not going to exist. So when I execute this, we'll get the first 2 file reads because they're successful, but we'll actually get that error message. And notice we get the error message first, because we hit the catch block before we hit the logging out of the actual retrieved data. So now I know you're thinking, well, this is all great and dandy, but when can I use this, right? Because generators are ES6 and I can't do that stuff yet, right? Actually, Chrome stable, Firefox stable, Opera stable, Node with the Harmony flag, IOJS, all of these things support generators right now. You can actually run all of this code that I just showed you in Chrome right now, or Firefox for you Mozilla folks. And if all of that fails because you have to support a certain unnamed browser, then you can use Tracer or Babel. And Tracer or Babel is going to transpile that code into ES5, and you're going to be just fine. I work in Node all day, so I don't have to worry about that stuff. But you can use this stuff all right now. So you really should not be using the code that I have for my denotify or my generator runner. They're great, but they don't handle all those situations. First of all, I'm assuming you're yielding me a promise. Most of the time, that's true, but what if you don't? You want to be able to handle those situations. Here's just a slew of libraries that you can use, and I'm not going to necessarily recommend any one of these because they're all actually very good. They all implement the things that you need. In fact, whatever async library you're using probably has a denotify, and it probably has some kind of generator runner. So look into these functions. Sometimes it's called spawn, sometimes it's called run, sometimes it's called other things. So find a library that works for you, and use the async and the denotify and the run methods that are in there. So some of you are going to be saying, what about ES7? Doesn't ES7 solve this problem? And some of you are saying, ES7, there's another one? Jesus Christ. So in ES7, we have async and await. And I hate to break it to you, but I've just wasted 20 minutes of your time because async and await blow away this entire process. Basically, the committee realized, oh, you want to do that? We can do that for you, and we'll do it more efficiently. And so now this is actually going to be native in the language. So instead of having a generator function, we'll actually have async as a keyword before the function. So we're indicating to the interpreter that, hey, this function is going to do some async stuff and might need to wait. And then we have the await keyword instead of yield. Now, in this example, it's operating exactly as a yield would. But we don't have to wrap it in all that other stuff. So await says, go do this asynchronous thing, give me back a promise. When that promise resolves, I'll put that result into that data variable. And when that promise rejects, I'll throw an error for you. Don't need to worry about any special handling or anything like that. And of course, the problem with this is, when can you use async and await? I have absolutely no idea. There is, yeah, sure, you can call it ES 2015 and ES 2016. Does that mean it's going to be done in 2016? And whether it's implemented, who knows? Nobody's really implementing async and await right now, except for the absolute bleeding edge. So you're not going to get this in the stable versions right now. You're not going to get this in Node right now. So you're going to have to wait a little while for that. That's it for me. So this was generating a new async. Thank you.